Hi guys, this is Antis. I hope everything is doing well at your end. I have just created a simple chatbot template using LangGraph framework, and I found this framework is really useful to store the chat history in my chatbot. And then the second thing also that with this framework, I'm able to add more functionalities to chatbot as I develop that chatbot in the future. So I'm going to share that codes with you, and I hope this is going to be useful for you as well. Hi guys, I have my notebook here. So I'm using OpenAI as well as Anthropic. So I have my key here, let me run it. And then second one is setting up the environment for both OpenAI key as well as Anthropic key. And then I'm using LangChain to run each of them. So here I have two functions here, LLM underscore OpenAI and LLM for chat Anthropic. So next one is I'm going to show it to you on how to construct the basic LangGraph flow. So I have imported a few things here, but let me highlight a few things that is important on this exercise. One is the human message and AI message from LangChain. So human message is to store the user input that we are going to provide into the chatbot. It can be using like a Streamlit or front-end UI, but in this example I'm just going to simulate that in this Jupyter notebook. And AI message is going to be the variable that's going to store the response from the LLM models. The next one is LangGraph.graph. This is a very important libraries that we are going to use to build the LangGraph. So the first one is the state graph. This is the class where we are going to create the instance of the graph that we are going to use in this exercise. We have start and end. I will explain later. The second most important thing as well is the add underscore messages. This is going to add simplicity into our codes because this is going to replace the append functions from the list. So when we have a new response, for example, after a user input, and we want to append that into the list, then we don't have to always use like the append method. We just simply add the response, and it's going to, and this functionality is going to assure that it's going to append, not override the existing message. So let's start with the process. So to begin with, for any LangGraph, we need to declare a state, a class of state, which is typically a dictionary. So we need to declare the key here, messages. Typically it can be anything, but just to make it intuitive, then I usually use the messages. And then here, as you can see, this is the important thing. So for every list that we are going to store the data of the user input or the response from the LLM models, then we need to add this functionality add underscore messages, which is going to assure that when we have a response from the LLM or when we have a new user input, we are going to append that into the existing messages, not to override the existing messages. Next one is to build or create the instance of the graph. So as I mentioned to you earlier, the main class that we are going to use in this LangGraph is state graph, and this state graph needs to connect with the class of the state here. So that's why I mentioned earlier, this is very important to always initiate the LangGraph codes or LangGraph structure with a class of state, where we are going to connect that with the main class of this graph, which is state graph. And then we can create functions. So for this example, we just create one functions just for simplicity reasons. And then the next one is we create the graph itself here. So as you can see, so I have created the graph here using the main class of state graph. Then the next thing is we can attach or add node into that graph, which is the functions chatbot here. We can name it here. The node usually like we name the same way as the functions itself, just to make it simple. And then we create the flow, which is we have it here as add underscore age. So we start from start and then go to the functions because we have only one functions. Then after we execute that one functions, then we go to the end. So as simple as that. If we have only one functions, in our graph. So once we have construct everything, we have the state here is connected to the state graph, and then we have the node, which is the functions that are going to execute the state, and then we have the flow here, which one to run first, second, and so on and so forth. And then we compile all of them, which is becoming a graph that we can execute. So let me run here. There will be no output. Oops, sorry, I need to run the state first. So I have the state run and then connected to the state graph here. Then we can run this second codes, which is going to build the graph based on the state graph, the nodes, as well as the flow that we have declared here. And then this cell is going to show us a simple visual representations of that graph. So you can see here a nice visualizations of the graph where it starts from start, and then the chatbot here, and then end. It doesn't show the state here that is connected to the state graph, but it's embedded inside the graph here. So let's run this chatbot using graph.stream method. So, and then we will see the results, like how the user input and response are recorded in this the graph. Tell me about reg system. So let's give it a few seconds and we'll get the response quickly. So yeah, we get the response here, the answer on the reg system, and my questions here, like tell me about the reg system, and I get the response here, which is with key name assistance, as I have put here in this graph stream. And then you can see here in the list, which is stored in the state, this is coming out from the class of state here, which is connected to the state graph. So it has the human message, which is from the user input, and AI message from the bot response. Now let's ask another questions. Let's ask about LangGraph. Tell me about the LangGraph. I want to show it to you whether this chatbot is going to store the previous questions and the response that I have here from my chatbot, or is going to override the previous one and start with the fresh one, the new one that I have just typed in, the new question. So this is my newest questions. Tell me about the LangGraph. And then you can see the updated state from the class of state here actually is overwriting the previous questions as well as the response. So it start fresh and recording the questions or user input that I have just typed in, and then the response from the LLM models, which is here. So the reasons why it doesn't store the previous conversation, because we are using the graph stream here. So graph stream never store the previous conversations or the chat history. So it's always going to start with fresh conversations. So this is not ideal in actual chatbot application. So I'm going to show it to you the second way, where we will store the previous conversation or the chat history to mirror the real applications of the chatbot. So here you go, the second one, which is going to store the conversation state, and we are going to use the graph.invoke functions instead of the graph stream. So on the first one here on the next cell, so it's similar to the previous code. So I have my messages here, AI message, human message, and then with functionality of add messages. And then I have added here user input. This is just the modifications that I have put here because I'm going to use the graph invoke. Let me run, and yeah, the initial state here, message is blank, user input just for testing only, nothing to worry about this one because we haven't built the graph yet. Let's add two functionality instead of one. So one is to capture the user input here, add user message. So whenever a user type in a request or a query that is going to be contained in this human message, and then it's going to be attached or append to the messages. Pay attention into this output that is written from this function. So I'm not using appending method from list. So I'm just attaching or assigning the new message into the dictionary, into the key value of messages, because this add messages is going to assure that the new messages is not going to overwrite the existing message, but instead going to append the new message. And then for the user input, this is this placeholder I'm going to put back into empty, because this is this is to capture the new request or the new query from the next question. So we always need to put this back into blank after we assign this user input into human message. Next one, the second function is a simple generate AI response with LLM invoke, and then we are going to pass the argument from the state messages, which is coming from the user input here. Same thing, so I don't use any append method, so I'm just attaching or assigning the response into the key messages, and then it will assure that the add underscore messages function is going to append the AI response, not to override the existing messages. Now the important thing is to build or to construct the graph instance and put together all the states and all the functionalities that we have created here. So we have one state here, as always, going to be one state. Functionalities, it can be more than one, so I have two here, but in any real case situations, it's going to be like a lot more than this, and it's going to be more complex than what we have in our example here. So first one is to connect the state graph, to the agent state here, the class agent state that we have declared here. So that's the very first thing that we always need to do when we create the graph. Create the instance and connect it to the state that we have declared in the very beginning. Once we have the graph instance declared here, then the next one is we connect or we add the node into the graph, which is we have two functions here. So we are going to create two nodes, one for each, one for user message and second one for AI response. Once we have the nodes, we have the state connected inside the state graph. Then the next thing that we need to do is that we need to create the flow, which is we have here a nice functions from graph called add underscore age. So we start from start, and then the first thing after start, then we proceed with the user message to take the user input, and then from user message we are going to generate the AI response from LLM models. Once we have the response back from the LLM models, then we go to the end and give the response to the users. Once we have everything, let's compile and then convert the graph structure into a flow that we can execute. And user message is not defined. Yeah, I need to click this one first, and you go, should be fine. Now let's test and run the workflow and see whether it stores the chat history. Tell me about the LangGraph. Let's give a few seconds and it will give us the response quickly. Okay, so yeah, nothing new here. Let me go straight into the updated states here. The messages is the human message, which is assigned from the user input. Tell me about the LangGraph. And then we have here the AI message, which is the response from the LLM here. And then the output looks like this. This is me. Tell me about the LangGraph. The questions from me, and then the bot response LangGraph, blah blah blah. Here the response is printed nicely here. Now let me ask the second question and see whether the second question as well as the response from the LLM model is going to override, or is just going to append into the existing data or updated state here that we have here. Tell me about reg system. Yeah, let's give another few seconds and we'll get the response quickly, and we can check quickly what's going to happen into the updated states or the data from the state. Yeah, let's go straight here. There you go. So it doesn't override, so we still have the first questions and the first response, and then the second question is going to be it was added here. There you go. Human message, tell me about the reg system, and the AI message, the response from the LLM, which is giving the response on the with regard to the reg system. So just to recap that what we have discussed here. So to build a graph that store the conversations, states, or chat history, we can use LangGraph. And then LangGraph need a state to begin with, so we always need to declare the states, and then we are going to assign that into the graph. And then the second component is the functionalities, the actions or the tasks that we are going to do with regards to the state itself, what we want to achieve from that state. And then we put them together. So we connected the state graph with the state, and then we also attach the functionalities here, and then we create the flow, we define the flow, and then we compile everything and then run the workflow. It will remember the chat history, which is going to be very important in real applications of chatbot. So with that, thank you. See you later on the other session.